Hey, welcome to the final installment of 1.3. In this video, we're just going to discuss a couple of word problems. Now, typically students tend to be a little bit frustrated with word problems presented in math classes because they feel like they have no real-world application. I kind of think that's a travesty. There's so many real-world applications to math that if you're not doing real-world applications, then why are you even bothering? I say that though, as we're about to go into doing a couple problems that don't have any real-world application. And that's just because where we're at right now, we can't do that many real-world problems yet. We just don't simply have the machinery. But so I've chosen to focus on two problems, both of which will have concepts that we will see later down the road. So these ones are important because the setup of these problems is going to come back later in problems that are a little bit more interesting and have a little bit more application. All right, so with that said, let's just jump right into it. So our first problem wants us to find the dimensions of a rectangle with a perimeter of 26 and an area of 40. So maybe the best way to start with a word problem is to draw a picture. This is a boring picture because it's just a rectangle. So we'll have one side X, one side of length Y, and we want to figure out what X and Y are. Now we know that the perimeter is 26. And so take a moment here, pause the video, think about how you would represent the perimeter in terms of X and Y. And when you've done that, resume the video. All right, so hopefully everyone came up with that the perimeter is going to be 2x plus 2y equals 26. And now pause the video again and do the same thing with the area. All right, and hopefully everyone found that the area is just x times y equals 40. Okay, so now we will hopefully be able to use quadratics to solve this equation. And the fact that this problem is coming from a quadratic section is a pretty good hint that we will be able to use quadratics. So first, we have two equations and two unknowns. We're going to try and solve for solely x first. So to do that, we start with our second equation, the x times y equals 40, and we divide x to the other side. That gives us y equals 40 divided by x. We're going to take that 40 divided by x and plug it in above. So we'll have 2x plus 2. We plug in for y, 40 divided by x equals 26. And now we have one term that's being divided by x, so it doesn't actually look like a quadratic yet. But if we take our solution, if we take our equation and multiply through by an x, so multiply both sides by an x, we find that we have 2 times x squared plus 80 equals 26x. And we'll subtract the 26x to the other side to find that we have 2x squared minus 26x plus 80 equals 0. At which point we can now divide by 2. So divide by 2 and find that we have x squared minus 13x plus 40 equals 0. And now we just plug this into our quadratic formula, and we get that x equals negative b plus or minus the square root of b squared minus 4ac, so that's 160 divided by 2a, so that's 2. So that's going to be x equals 13 halves plus or minus 3 over 2. And sorry for skipping some steps. In the middle of this, I'm just trying to save space. And that's going to tell us that x is equal to 13 over 2 plus 3 halves, which is 8 or 5. And we'll see that these are the two dimensions. If x is 8, then y ends up having to be 5. We can get that by just looking at our condition that x times y equals 40. So if x equals 8, then 8 times y equals 40. So y equals 5. And similarly, if x is 5, then y is going to have to be 8. So our dimensions are 5 by 8. So the crucial steps here are that we are able to draw a picture of our rectangle, and then say exactly what the perimeter and area formulas are in terms of x and y. We're able to say that 2x plus 2y, that represents our perimeter, and x times y, that represents our area. And then it's just solving for one. So we solved for y, and then plugged that y equation into our other equation. And that was able to give us a quadratic. And then we just applied our quadratic techniques to find a solution. All right, and so for our next example, we have a ball thrown from the top of a 90-foot building, and its position above the ground is given by this equation. And we want to figure out after how many seconds does it hit the ground. So basically our picture is we have a building, a person on top who threw a ball, and that ball is just flying with a trajectory. And now some of you who may have studied physics in high school know that the trajectory of a thrown ball has to follow that of a quadratic, assuming a little bit of simplification, of course, ignoring air resistance. And that this quadratic form happens because the ball is accelerating with respect to gravity as it falls. So as it falls, it gets faster and faster. So for a while, it's able to travel a little bit of a horizontal distance, but then it's just moving downwards so fast that it can't travel horizontally much further than it already did. Right, but we just want to know how long it takes before it hits the ground. And so we have that its height above the ground is modeled by this equation. And so when it's on the ground, the height's going to be 0. So that just means that we're just trying to solve for time for 0 equals 96 plus 80t minus 16t squared. All right, so So this whole quadratic is actually divisible by 16, which is really nice. That'll allow us to do some quick factorization. And if you didn't see that right away, the other way to figure that out is just start by pulling out factors that you can see. So for instance, each of these coefficients are even. So we can pull out a 2. So that gives us 48 plus 40t minus 8t squared. And now maybe we recognize that each of these terms, each of these coefficients are divisible by 8. So we can have 2 times 8 times 6 plus 5t minus t squared. And that's our 16. And so we just divide that 16 to both sides and then solve for 6 plus 5t minus t squared equals 0. And now we just apply the quadratic formula. Now it's important not to get tripped up. So our b, so we have x equals negative b plus or minus the square root of b squared, so that's 25, minus 4, our a, and in this case, our squared term, t squared, is on the far right. So the coefficient for a is -1. Oh man, I'm sorry. Is -1, and the coefficient for our c is 6. And we divide everything by -2. So that gives us -5 plus or minus the square root of 25 plus 24. So that's 49 over -2. It's gonna be -5 plus or minus 7 over -2. And so that gives us 2 solutions, which I'm actually gonna write on the bottom right. So then x equals, we have either 6 or we have -1. And I'm sorry, I switched to x when we had t's. So let me switch those to t's. All right, we have 2 solutions for t. One of them is the correct solution, and one of them is not the correct solution. So take a second and see if you can figure out which one is correct and which one is not correct. Just pause the video and think about it. All right, so hopefully we were able to reason that t equals 6 is the correct answer, because t is a unit of time. So we said 6 seconds pass. If t was -1, then we think about our answer. We just said -1 seconds passed since the ball hit the ground. We don't even know what that means. Like it's just nonsense. We don't know what it means for -1 seconds to have passed. So therefore, t equals 6 is the correct answer. All right, that was 1.3. Now 1.3 is one of the longest sections in the book. So other sections, the videos should be a bit shorter. I think the best thing to do now is just do a lot of practice problems. That's really the way you learn. Listening to lecture only gets you so far. I see lecture as just a way to show you guys what to do. I'm showing you the techniques and how they work, but it's really all about the practice you put in. That's how you master it. Just practice, practice, practice. And that really applies for all things in life, not just math. anything you want to get good at, you really need to practice and not only watch videos of people doing it. So the videos should just be seen as a guide on how to do it. And now it's your turn to actually put the pieces together and solve equations. So there are my math lab assignments and homework assignments. That should be an adequate amount of practice, but I wouldn't hesitate to do more. I'm a big believer that if you just do 5 or 6 problems a day, every day, then you're going to be fine. That's all it takes. It should only take about a half hour of studying every day, and you'll be golden. All right. See you all in a later video series. Good luck.